To solve this quadratic equation, first I'm going to get all of my terms on one side of the equal sign. So I will subtract 4 from both sides of the equal sign so that my equation is set equal to 0. I can subtract 4 from the constant 28, so that becomes plus 24. So we have 3m squared minus 18m plus 24 equals 0. From there, we want to see if we can factor out a GCF. And in this case, we can, because all of our terms are divisible by 3. So we put the 3 out in front because we are going backwards. We're factoring what multiplies to give this polynomial. So we divide 3 out from each term, and we're left with m squared, 18 divided by 3, minus 6m, 24 divided by 3, plus 8 equals 0. From here, my next suggestion is to always try to factor your quadratic that's remaining. Notice we have, with what's inside the parentheses now, we have an a value of 1, which makes factoring a lot simpler because you're simply looking at what two numbers multiply to give C and add to give B. So what two numbers multiply to give 8, but add to give me negative 6? Well, the only way to multiply and get a positive and add to get a negative is if you have two negatives. Two negatives times a negative times a negative is a positive, and then when you add two negatives, you have a negative. So we're looking for two numbers multiplying to give 8, so 1 and 8 or 2 and 4, but add to give 6, that would be negative 2 and negative 4. So inside the parentheses, the 3 is still outside, 3, and we can now break that down even further into factored form, and we have m minus 2, because that was one of our solutions there, and then we have m minus 4, our other number that we got when we did our factoring. Now that we have it in complete factored form, from factored form, we solve using the zero product property, set each factor with a variable, so that would be m minus 2 and m minus 4 equal to 0, and solve. We solve m minus 2 equals 0 by adding 2 to both sides, so we get m equals 2. We solve m minus 4 equals 0 by adding 4 to both sides, so we get m equals 4. Those are the solutions I could find by factoring. We've also learned how to complete the square to solve a quadratic. So let's look at how could we complete the square. So if we have an equation like p squared plus 14p plus 35 equals 5. Get it set equal to 0, subtract 5 from both sides. P squared plus 14p plus 30 equals 0. And we don't know, we have to use completing the square here until we factor. So let's go ahead and try to factor. Maybe it can be factored. So what two numbers multiply to give whatever a times c is, and since a is 1, that would just be 30. What two numbers add to give b, which is 14. So let's work through our factors of 30, 1 and 30, 2 and 15, 3 and 10. 4 doesn't divide evenly into 30, 5 and 6. So if we're multiplying to get a positive and adding to get a positive, both of our numbers have to be positive, and none of these, when we add these, none of them equal 14. So this is an example of a problem that can't be factored. So we would want to try, all right, well, a equals 1. That makes it easy to complete the square if a is equal to 1. It's even easier if b is 2. So let's try completing the square here. So when we complete the square, we want to focus on our variable terms and what value must be added to make p squared plus 14p a perfect square. There's a formula for that. You got to remember b divided by 2 squared, because that is the value that must be added to make it a perfect square trinomial. So 14 divided by 2 is 7, and 7 squared is 49. So I am going to add 49 to both sides of this equal sign. So we've got p squared plus 14p and we are going to add 49 to both sides of the equal sign. What you do to one side, you have to do to the other. So I haven't changed the equation. I still have p squared plus 14p plus 30 equals 0. All I've done right now is I've added 49 to both sides. The reason I've done this is so that I have this perfect square trinomial that can be factored. So now I can say what two numbers multiply to give 49 and add to give 14. We already know the answer, 7 and 7. So my factored form is p plus 7 times p plus 7, which when you have a perfect square trinomial, that means you're multiplying two binomials, a binomial times itself. So that's p plus 7 squared is another way to write that. We still have that plus 30 here and equals 0 plus 49 is 49. Now, if we're trying to solve this equation, we can now get the p plus 7 squared. Let's get that by itself. So we'll subtract the 30 from both sides. P plus 7 squared equals 19. Now, what's the inverse of squared? I take the square root to cancel out the squared. What I do to one side, I have to do the other. So square root of 19, irrational number, that's okay. Real, not imaginary, because it's not a negative, but it's irrational, but that's okay. We're just going to leave it as square root of 19. And that's already in simplest form because the radicand has no perfect square factors. So now we've got p plus 7 equals plus or minus square root 19. When we take square root to solve an equation, we always have the positive or negative root. So plus or minus square root of 19. Last step to solve for p, only one step to get p by itself, and that is to subtract 7 from both sides. We're going to put that rational negative 7 in front. So it's negative 7 equal plus or minus the square root of 19. So p is equal to negative 7 plus the square root of 19. P is equal to negative 7 minus the square root of 19. And these would be my exact solutions. And I could do the computation and get a decimal rounded to whatever if I wanted to come up with some kind of estimate for those two values.